Okay, so good evening here, Mr. Mlenga. And we have this question, which is the area of a sector. And if I might say, mathematics does not change, it's the same. So this concept is actually emerging from the area of a sector. We all know the area, or rather, the area of a circle. We know what a circle is. So if this circle is actually partitioned with three things, but rather, there's part of an arc, the part of the circumference, which you can call the arc length, the radius, and another radius. So these two radii can actually give us an angle. So this angle represents a fraction within within the circle. So if we know how to find the area of a circle, the area of a circle is equal to pi r squared, where the r is the radius, the pi is a constant, which is mostly pi 1 is 22/7. But now, because this, which we are calling the sector, is just the fraction within the circle, so we can actually multiply by the fraction, which is just the angle over 360. So this angle represents the encroachment of the radii, and then the 360, this is a sum total of the angles within the circle. But in most cases, these things come this side, where we say theta over 100 over 360, then multiply by the pi r squared. So the concept is actually the same. So this gives us the formula for finding the area of a sector. So I have these two questions that I want us to solve. We have that question, we also have that question, and then I give you something to do. It's just a quick task. So the question says that came in 2017. The diagram below shows, the diagram below is a sector actually with the radius O, and then we are also given the angle, which is 270, as well as the radius. So we are actually told to calculate the area. So the area, we start with the formula, because the formula helps us to defend our answers. We're actually saying the answers that we're going to produce is rightfully ours because we have indicated the formula that was used in the computation. But now, by the virtue of mathematics paper 1, where calculators are not allowed, I will advise you guys not to do the direct multiplication, but just divide. So the angle is 270 over 360 multiplied by the pi is 22, not the lambda they used, it's pi. 22/7 multiplied by the radius, which is 7 and 7. So without wasting much of the time, actually the 7 cancels another 7. We can have a 0 and a 0, so that we only remain with 27 multiplied by 22 multiplied by 7 divide by 36. So what else can we actually use? We can use a 9, where a 9 can go into 36 4 times. So let's try using a 9. We use a 9 here. 9 into 36 gives us 4. 9 into 27 gives us 3. And again here, I can actually use a different color, where I can have 2 the 1, 2 the 11. So at the end, I'm going to have 3 times, or 2 into 4, it's 2. So I'm going to have 3 times 11, 3 times 11 times 7, then divided by 2. So 7 and, let me go this way. So 7, so area is equal to, so 3 here, multiplied by, so 7 and 11 gives us 77 divided by 2, and most definitely here you can actually compute. Because 2 there, it's 30 what? What is 2 into 2 into 77? That is 38.5. You actually multiply by 3, it gives us 115.5 centimeters squared as the area of a sector. So do not stress multiplying the big numbers there. Please reduce by the means of a division so that you get to have a smaller number. Very important. You will never go wrong, because this division you are doing, you're actually reducing the numbers so that at the end of the day, you get to have a smaller number, which will be easier to deal with. The next one is actually here. So the other one, they told us to find the area. This one, the area is already there. We are actually just told to find the theta. So the concept still remains the same. Start with the formula. Area is equal to pi, or let's say theta, over 360, n pi r squared. But this number here, which is an improper fraction, can be written as a improper, it is a mixed fraction, where I will have to multiply the denominator and the whole number. So 3 times 25 gives us 75. We add a 3, that is the information shown over here. So actually this number is translated into 77 over 3. So we multiply the numerator and the whole number, then we add to a denominator, it gives us 77 over 3. So this is the area that we have. The area that we have is 7 over 3. 7 over 3 equal to, the angle is what we are actually looking for. We do not know it. Multiply by the pi is 22 over 7. 22 over 7, and the angle is divided by 360. We also multiply by the radius, which we have, it's 7 by 7. So maybe before we even go any further, let's see if we have numbers that can actually reduce. Yeah, we do have a 7 and a 7. Of course, we have a 2 that can go into 360, giving us 180. The same number can actually go here. 2 gives us 11. So we now gonna multiply the denominator on the left and the numerator on the right. So these are the odd numbers that are remaining. So we're gonna have 3 multiply by 11 multiply by 7 multiply by theta. Allow me to use theta with Q because I don't have a theta on my keyboard. And then that we now multiply the other entities. The other entities are actually the 77 as well as 180. So when we multiply that, we're going to have 77 multiplied by 180. So we have to divide by any number written before the parameter that we're looking for. In short, we're making Q subject of the formula. So we actually gonna divide by 3 multiplied by 11 multiplied by 7. This is the best way so that you do not get bigger numbers at the beginning. So we're going to divide the same number, actually both sides. And then once that happens, we can see that the 3 cancels the 3, 7 cancels the 7, and 11 cancels an 11. What remains is actually theta. And then these two numbers here, when we multiply them, they'll actually give us 77. So that 77 and that 77 cancel out. The only thing remaining is 180 divided by 3. And at the end of the day, you absolutely get a number that is easy to do. Now, remember, if these numbers, the 77, 180, were multiplied, we're going to have a very big number, which could actually be difficult to even handle. So that's how best we play around such questions. So I hope you enjoyed the little session that we had. So I have these two questions. The first question, the other one is gone. I have this question left for you. I want you to solve it. I want you to send on WhatsApp to that number, and then I review it. Okay? That is what I actually want. Yeah, so if you can actually attend to it now, that would be lovely. So thank you very much for your time. Allow me to capture this and maybe upload it in the description of the video so that those who are interested to see can actually see it better and solve. So thank you so much and enjoy the video.